Hi everyone, good evening. Good evening everyone. So today we'll finish context-free languages and we'll start Turing machines, okay? So this is the QR code of my compiler design textbook. This textbook will be helpful for BTech, MTech and GATE. You can buy a copy from PW store. This is the QR code, please scan this. And this is the QR code of my Telegram channel. You can join the Telegram channel. Lots of discussions happen there, okay? Now, yesterday we were looking at context-free languages. Today also we will see context-free languages, and after completing context-free languages, we'll start Turing machines, okay? After completing context-free languages, we will start Turing machines, okay? So, there exists an algorithm to check if a given grammar is LLK for a given value of k, so it is decidable. Okay, what does that mean? You can say whether a grammar is LLK or not using an algorithm, so it is decidable, right? Yeah, Sunil, 1 year is sufficient. And also you are from NIT, so it will be easy for you. One year is sufficient, Sunil. You can definitely get under 100. Okay. Not even 1 year, 6 months is sufficient. Now there exists an algorithm. To check if a given grammar is LRK for a given value of k, which means decidable. Right? If a grammar G is LRK, such that k is greater than or equal to 2, then there exists a grammar G1 which is LR1 for the same language, What does this mean? This means that if you have LR2 or LR3, LR4, so on, all of them can be converted into LR1. All of them can be converted into LR1. That is the meaning of it. for all DCFL for all DCFL with prefix property for all DCFL with prefix property we can generate LR0 we can generate LR0 parsers. We can generate LR0 parsers, right? So what does this mean? If we have DCFL and then if we have DCFL with prefix property, DCFL with prefix property, DCFL with prefix property, then there exists LR0, then there exists LR0, right? So what is prefix property? So what is prefix property? So what is prefix property? Right? Prefix property. Prefix property. So DCFL, a DCFL L has prefix property. A DCFL L has prefix property if for all W belongs to L, for all strings belongs to L, there is no proper prefix of W belongs to L, right? Which means if you take proper prefixes, they should not belong to L. If W belong to L, then no proper prefix of W should belong to L. What does that mean? Let us take an example. L equal to 0, 1, 1, 1, 0, right? What are the proper prefixes of this? Epsilon is a proper prefix, 0 is a proper prefix, 0, 1 is a proper prefix. What are the proper prefixes of this? Epsilon is a proper prefix, 1 is a proper prefix, right? Now, none of the proper prefixes belong to the language. Therefore, this language has prefix property, right? Therefore, this language has prefix property, right? And it is a regular language, and so DCFL. So this is a DCFL with prefix property. This is a DCFL with prefix property. So LR0 parser is possible. LR0 parser is possible. LR0 parser is possible, right? Now I'll give you a grammar. Tell me if prefix property is there. L equal to 0, 1, 1, 1, 0, 1. Tell me if prefix property is there. 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 Does this language has prefix property? Does this language has prefix property? Right, Prashant, is it having prefix property? Are you sure? No proper prefix should belong to the language. No proper prefix should belong to the language. No proper prefix should belong to the language. Pricey angel. Right. So, what are the proper prefixes of this? Epsilon, 0, 0, 1. So, all these three are not there in the language. So far no problem. What are the proper prefixes of this? Epsilon and 1. Now, 1 is a proper prefix of 1, 0 and 1 is also present in the language. So, we can say that no prefix property. It does not have prefix property. No prefix property. So, we can say that no LR0 is possible. No LR0 is possible. We can say that no LR0 is possible. No LR0 is possible. Right? But the language is regular. But the language is regular. And it is also DCFL. Language is regular. And it is also DCFL. So LR1 is possible, right? So LR1 is possible. For every DCFL, LR1 is possible. LR1 is possible, right? Now I'll give you a language. Tell me if prefix property is there. L equal to A star B star. L equal to A star B star. Tell me if prefix property is there. Tell me if it is LR0. Tell me if it is LR0. Check for prefix property. Hi Chandan Azad. Tell me if it has prefix property. Tell me if it has prefix property. So if you write A star B star, you will get it, okay? Write A star B star and find the proper prefixes of all of them. Write A star B star and find the proper prefixes of all these strings. You'll understand. If any proper prefix belongs to the language, then it has no prefix property. Then it has no prefix property. So, very good, Chandan. So, there will be epsilon, there will be A, there will be AA, there will be AAA, so on. There will be B, there will be BB, there will be BBB, so on. There will be AB, there will be AAB, but you don't have to write all these things, even simply you can answer it. Now if I take A, the proper prefix is epsilon and it is present in the language, right? So whenever epsilon is present in the language, it does not have prefix property, right? So it does not have prefix property, no prefix property. Therefore, no LR0 is possible, right? But the language L is regular. But the language L is regular. But the language L is regular, which means it is DCFL. Therefore, LR1 is possible. Therefore, LR1 parser is possible, right? Right. Now answer this one. A power n, B power n such that n is greater than or equal to 0. A power n, B power n such that n is greater than or equal to 0. Is it LR0? Is LR0 possible? Is LR0 possible? Answer this. Is LR0 possible? Is LR0 possible? Is LR0 possible? Is LR0 possible for this language? Right? Not able to do this. So n is greater than or equal to 0, right? So epsilon is there in the language, AB is there in the language, AABB is there in the language, so on, right? Now if you see for AB, epsilon is a proper prefix. Now epsilon is there in the language. Whenever epsilon is there in the language will not have prefix property. So there is no prefix property. 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 So we can say that it is LR0. No LR0. no LR0, right? But this is a DCFL. This is a DCFL, right? So we can say that LR1 is possible. LR1 is possible, right? Answer the next question. A power n, b power n such that n is greater than or equal to 1. A power n, b power n such that n is greater than or equal to 1. A power n, b power n such that a power n, b power n such that n is greater than or equal to 1. I forgot your name, motivation all time for life. I forgot your name. So answer for this, a power n, b power n such that n is greater than or equal to 1. Does it have prefix property? Does it have prefix property? Okay, Prince. Vidayak. Namaste, Vidayak. So Prashant, what about this language? Does it have prefix property? Does it have prefix property? A power n, b power n such that n is greater than or equal to 1. Excuse me. So write down these strings. Very good, Prashant. So write down these strings and you check it. Maybe you can take a string as an example. Let us say AABB. What are the prefixes? Epsilon, A, AA, proper prefixes, AAB. None of these belong to the language because number of A's is not equal to number of B's. Always last B will be missing because we are taking only proper prefixes, not prefixes, right? So last B will always be missing in the proper prefixes. Therefore, and also epsilon is not there in the language, right? So it has prefix property. So it has prefix property. Now if it has prefix property, this is a DCFL with prefix property. Therefore it is LR0. If it is LR0, it is LR1. If it is LR0, it is LR1 also. It is LR1 also, right? Now answer this question. A plus B star, is it LR0? 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 Okay, Prashant, tell me for this language. A plus B star. Very good, Prince. There is no prefix property here, right? So what are these strings? These strings you will get are minimum is A, 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 and then A is followed by B's will also be there, but here only you can tell the answer, right? If I take the proper prefixes of A, I will get epsilon and A belongs to the language, and A belongs to the language, right? Therefore, there is prefix property. There is prefix property. There is prefix property. So there is no prefix property. So no LR0, but the given language is regular, right? Which means, but the given language is regular, which means it is DCFL, which means LR1 is possible. LR1 is possible, right? Now, L equal to W such that number of A's in W is equal to number of B's in W, and string length is greater than or equal to 2. And string length is greater than or equal to 2. Number of A's in W is equal to number of B's in W. Tell me if it is LR0 or not. 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 Tell me whether this is LR0 or not. Very good. Not LR0, right? Why? For example, if you take ABAB, which is in the language, one prefix is AB, proper prefix is AB, which is also in the language, right? Therefore, you can say no prefix property. You can say no prefix property, which means not LR0, not LR0, right? But this language is deterministic context-free language. Therefore, LR1 is possible. Therefore, LR1 is possible, right? Now we have seen various algorithms in context-free grammar, context-free languages. We have seen various algorithms in context-free languages, right? So one is removal of epsilon productions. We have seen removal of epsilon productions. We have seen, right? And removal of unit productions. We have seen removal of unit productions. We have seen, and removal of useless productions. We have seen removal of useless productions. We have seen, and we haven't seen removal of left recursion. Removal of left recursion, and we haven't seen removal of non-determinism. Removal of non-determinism. Removal of non-determinism we have not seen. And then we have seen conversions. And then we have seen conversions. And then we have seen conversions, right? So we have seen how to convert a context-free grammar to CNF, and how to convert a context-free grammar to GNF. How to convert a context-free grammar to CNF, how to convert a context-free grammar to GNF, right? So these are various algorithms we have seen. We have to see removal of left recursion and removal of non-determinism. Okay? Okay? Very good, Prashant. Very good, Prashant. Very good, Prince. Okay? Fine. So, epsilon and unit productions, epsilon and unit productions have to be removed before a grammar is converted into CNF or GNF. Before a grammar is converted into CNF or GNF, you have to remove we have to remove epsilon productions and unit productions, right? Now removing epsilon production, is not possible is not possible if the language contains epsilon. If the language contains epsilon, removing epsilon production is not possible, right? So for all context-free grammars, which are epsilon free, for all context-free grammars which are epsilon free, there exists a CNF. For all context-free grammars which are epsilon free, which means which does not have epsilon, there exists a CNF. Right? Similarly, we can write the same for GNF also. For all context-free grammars, which are epsilon free, there exists a GNF. So tell me whether this statement is true or false. For every context-free grammar there is an equivalent CNF. For every context-free grammar, there is an equivalent CNF. Tell me whether it is true or false. For every CFG, there exists a equivalent CNF. True or false? For every CFG, there is an equivalent CNF. For every CFG, there is an equivalent CNF. So this statement is false. The reason is, if the grammar contains epsilon production, which means if the language contains epsilon, then the grammar will definitely contain epsilon, and for such grammars we cannot give CNF or GNF, right? Now what is the order in which you should minimize a grammar or convert a grammar? First thing is, you should eliminate epsilon productions. Second thing is, you should eliminate unit productions. And third thing is, you should eliminate useless symbols. You should eliminate useless symbols, right? Now, presence of epsilon presence of epsilon presence of epsilon production in the grammar doesn't mean epsilon is in the language. Tell me about this. S derives AA, A derives epsilon. Is epsilon in the language? Presence of epsilon production doesn't mean epsilon is in the language, right? Presence of epsilon production doesn't mean epsilon is in the language. So there is epsilon production present, but it does not mean that epsilon is in the language. Why? Because the string generated is S derives A derives epsilon. So the language does not contain epsilon. The language contains A. Right? If epsilon is present, in the language, then there will be, if epsilon is present in the language, then there will be at least one epsilon production. In the grammar. Then there will be at least one epsilon production in the grammar. right? Right. Tell me about this. S derives AB or AB or B. B derives AB, capital AB, BA. A derives epsilon. A derives epsilon, right? Can you eliminate epsilon productions from this? Can you eliminate, or tell me if epsilon is present in the language or not? Tell me if epsilon is present in the language or not. Tell me if epsilon is present in the language or not. Hi Kiran, this is not good evening. This is good night. Kiran, what happened to your old ID? Kiran Bharadwaj. You have changed your ID to a new one, is it? You have changed your ID to a new one. Tell me if epsilon is present in the language. Tell me if epsilon is present in the language. So you have to see what are all the variables that are nullable. What are all the variables that are nullable? So A derives epsilon, A is nullable. See if only A is in the right hand side. Only A is not in the right hand side here or here. So B and S are not nullable, right? So S is not nullable, so epsilon is not present. S is not nullable, so epsilon is not present. S is not nullable, so epsilon is not present. Right? 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 Now I'll give you one more grammar. Tell me if epsilon is present. S derives AAB or AA or B. B derives AB or AB or A. A derives epsilon. A derives epsilon. Tell me if epsilon is present or not in the language. Tell me if epsilon is present or not in the language. What, Prashant? Epsilon is present, is it? Epsilon is present, is it? Let us see nullable variables. Let us see nullable variables. Let us see nullable variables. Okay. So what are the variables that are nullable? What are the variables that are nullable? So A is nullable. Now because A is on the right hand side of B, B is nullable. And because B is on the right hand side of S, S is nullable, right? So when S is nullable, epsilon is definitely present in the language. When S is nullable, epsilon is definitely present in the language, right? Now when is a symbol or a variable useful? A variable V is useless. A variable V is useless if it doesn't appear in any sentential form. Right? So can you write down when a variable is useful? Can you write down when a variable is useful? There are two conditions, right? Can you write down the conditions when a variable is useful? Can you write down the conditions when a variable is useful? Write down an expression telling when a variable is useful. Okay? Write down an expression telling when a variable is useful. So you can write like this. Useful symbols you can write like this. Useful symbols equal to V such that V is present in a sentential form. V is present in a sentential form and V is deriving a word. V is deriving a word. W belong to T star, right? Which means V should be reachable. V should be reachable and we should be deriving a string. Then only it is useful. Okay, fine. We'll end the class here. Good morning, everyone. It is 12 o'clock. We'll continue tomorrow with Turing machines. Okay.